Hey, what's up everybody? In this lesson, we're going to take a look at isotopic notation for ions. Let's begin by describing what exactly an ion is. So an ion is just an atom. That's it. It's nothing fancier than that, but it's a special kind of atom that has a positive or a negative charge. So an ion is a charged atom. For example, if this circle represented a chlorine atom, and that chlorine atom had a -1 charge, then you could call that an atom of chlorine because it is an atom. But because it's an atom with a charge, you could also refer to this as a chlorine ion. This is caused by an imbalance of protons and electrons, and that's because protons are positive and electrons are negative. So if the amount of protons equals the amount of electrons, like if there was 10 protons in the nucleus, and then outside that nucleus there was also 10 electrons, if they balance out, they cancel each other out, and you end up with a neutral atom. But if those 10 protons had 11 electrons, then you're going to end up with an ion that is negative overall because those electrons have the higher score, basically. I sort of think about this like two competing teams. That's going to give you a negative ion. And in the isotopic notation, that XZA format we talked about in the last lesson, if there is a charge, then that charge is going to get listed right here in the top right-hand corner, along with the atomic number and the atomic mass. Here's that carbon atom again, and we can now write the full isotopic notation for this, starting with the symbol, capital C for carbon. The atomic number is 6 because carbon has 6 protons. We can't see them all, but I believe there are 6 neutrons in that nucleus. So this has an atomic mass of 12. Now it can also include the charge if there is one. So I'm going to put the positive team, the protons. Remember, there's 6 of those. And now I need to count to see how many electrons there are. 1, 2, 3, 4, 5, 6, 7, and 8. 6 to 8. So you can see that the negative team is winning by 2. And if the negative team is winning by 2, then this gets a charge of -2. So that's pretty much it as far as the information goes. This video is also going to contain a chance for you to practice some of these skills with isotopic notation. At this point, it would be a good idea if you pause the video to try to do as many of these yourself as possible. And then once you're done, you can click play again to watch me go over the answers. Assuming you've done that, let's get started with question 1 that asks us how many protons, neutrons, and electrons would be found in each of these atoms. So first, magnesium, you can see the bottom left has an atomic number of 12, so there's 12 protons. Its mass is 24, which means 24 minus 12 means there's got to be also 12 neutrons. The electrons, because there's a charge of +2, that means the positive team is winning by 2, right? +2, positive team winning by 2. So if the positive team scores 12 to be winning by 2, the negative team score has to be 10. Same thing for arsenic, it's going to have 33 protons. If you do 75 minus 33 to find out how many neutrons there are, you end up with 42. And the electrons, we're going to look at the charge of -3. This means the negative team has to be winning by 3 for a total of 36 electrons. For number 2, just to save time, I'm not going to go over each of these rows in detail. We're going to do just a detailed look at this middle row as a good example of what's going on here, starting with the fact that this is calcium. If we know that it's a calcium atom, you can go to a periodic table and look up that the atomic number of calcium is 20. That also means there has to be 20 protons. Next, I'm going to compare the protons to the electrons, positive team versus negative team, to see what type of charge we have. Clearly here the positive team is winning by 2, so this calcium has a +2 charge with a mass of 41 and 20 protons, and that means there must be 21 neutrons. The only other thing is to finish off the isotopic notation with 20, 41, and the +2 charge. So here's the answers for the other 2 rows, just so you can do a quick self-check on how you did with those. Now let's jump down to question 3, where we will probably go over each of these things. We'll move a little faster through the first 3 because they're fairly straightforward. If you've got 13 protons like 3A describes, a periodic table can tell you that that is an atom of aluminum. And if there's 15 neutrons, 13 plus 15 will give me a mass of 28. Notice it says here that you can assume the atom is neutral unless otherwise stated. And it doesn't say anything about electrons or the charge, so I'm going to assume that there is no charge. In letter B, kind of uniquely, all it says is that the atomic number is 41. You can take that and look up that this element is Nb, but that is the only information we know about this particular atom. It doesn't tell me anything about the neutrons, so I don't know the mass. It doesn't tell me anything about the charge, so I'm going to assume it's neutral. So while this wouldn't be a complete isotopic notation, it is the only isotopic notation we can be sure about for this particular atom. For letter C, we've got 33 electrons and 42 neutrons. It doesn't tell me what the protons are, but because we are assuming the atom is neutral unless otherwise stated, there must also be 33 protons. So my atomic number is 33. This tells me I'm talking about arsenic with a mass of 33 plus 42, and that would be a mass of 75. D and E are a little bit more challenging because they're giving you this information in a unique way. Letter D says that iron has 84 total subatomic particles. So right off the top, I know that it's iron, so I can start with the symbol Fe. I can also look up that iron has an atomic number of 26 and fill that in. So the real challenge here is figuring out what isotope of iron this is. What mass does this iron atom have? This can be figured out based on the fact that this atom has 84 total subatomic particles, and if you didn't know what that means, here's what it means. That means the protons and the neutrons and the electrons, all 3 of them added together, must add up to 84. With that little equation written out, we can start plugging some stuff in, like the 26 protons that it has to have. If it's neutral, unless otherwise stated, I also know that there's 26 electrons. This allows me to figure out how many neutrons there are by doing a little bit of algebra. 84 minus 26, and then minus 26 again. This tells me that there are 32 neutrons in this iron atom. The final step is to combine 32 with 26 to get the mass, and this comes out to 58. So my iron atom here has to have a mass of 58. If you do all of the same stuff with this description here, rubidium that has 124 total subatomic particles, you get Rb 3787. That also wraps it up for this lesson on ions and isotopic notation. Thanks a lot for watching.